Have you ever wondered how an AI like OpenAI's Codex can feel like the exact same assistant, whether you're using it in a simple terminal or a really complex code editor? Well, today, we're going to pop the hood and see exactly how they pulled that off.
All right, let's just jump right into the big engineering puzzle OpenAI was up against. Imagine you've built this incredibly powerful AI coding agent. The thing is a genius. But how do you get it to show up and work the same way everywhere? We're talking the commands line, a slick web app, and right inside your IDE like VS Code. That is a huge challenge.
So here's the deal. Codex has to exist on all these different surfaces, as OpenAI calls them. You've got the CLI, a web app, an IDE extension, you name it. And if you want users to have an experience that doesn't feel, totally disjointed, all of these phases have to be powered by the very same core logic. Now, you could try to rebuild the agent's brain for every single platform. And let's be honest, that's a recipe for disaster. It's inefficient, it's going to be full of bugs, and you'll never get a consistent feel. They even tried some early experiments, like using a generic messaging server for the VS Code extension, but it was clunky. It just wasn't the right tool for the job. They needed something much, much better. This search for a single unified approach led them to what I think is a really elegant solution. The absolute best way to think about it is like a universal translator for the AI agent itself. And here it is, the hero of our story, the Codex app server. At its heart, it's a special kind of API, one that can talk back and forth, and it serves as the one and only connection between any app on the front end and the core brain of Codex on the back end. And yeah, this universal translator idea really is the perfect mental model. It doesn't matter what language the application is speaking, could be TypeScript in VS Code, JavaScript in a web browser, whatever. The app server takes those requests, translates them into a language the core agent understands, and then translates the agent's thoughts and actions right back. Of course, for any translator to actually work, everyone has to agree on a common language. So to make this all possible, OpenAI designed a communication protocol built on just a few simple but really powerful core concepts that any application can easily understand. And believe it or not, this entire complex system is built on just these three fundamental ideas: an item, a turn, and a thread. Seriously, every single thing that happens in a conversation with Codex can be described using these three building blocks. So let's break them down. First up, we have the item. Think of this as the atom of the conversation, the smallest possible piece. An item could be the message you type, it could be the agent showing its thought process, or it could be a chunk of code. The key thing is that every single item has a very clear start and a very clear end. That's super important for the UI. Okay, so once you have items, you can group them into a turn. A turn is basically one complete back and forth. It kicks off with your request, say, run all my tests, and it includes all the different items the agent generates until it has completely finished that job. And finally, all of those turns live inside a thread. The thread is the container for your entire session. It keeps a full history of the conversation, and because it's durable, you can literally pause what you're doing, close your laptop, come back a day later, and pick up right where you left off. It just works. What's so brilliant about this whole system is that it creates this incredibly rich, streaming interaction. Instead of you sending a request and just waiting for a final answer to pop up, the app server tells your client immediately that work has started. Then it streams back all the items as they happen. This is exactly why the agent feels so responsive and alive. So, we've got this really elegant protocol, but how do different apps actually plug into this Codex Harness in the real world? Well, the architecture is super flexible. For local apps like an IDE extension, the app server is just bundled right in and runs on your own machine. But for the web version, the app server runs in a container on OpenAI's remote servers. This is really clever because it means all the heavy lifting happens in the cloud, keeping the UI in your browser incredibly fast and lightweight. And this quote from the team really nails the killer feature of that web architecture. Because the agent's state, its memory, its progress, is all on the server, your work just keeps on going, even if your internet cuts out or you accidentally close the browser tab. You can just reconnect and boom, everything is right there waiting for you. Okay, so let's zoom out for a second. We've been down in the weeds with the technical details, but why is the standardized approach so important? What does it mean for the future of AI agents?
Well, it matters because it creates a stable, first-class, officially supported way for anyone to build on top of Codex. Now, sure, there are other, more limited ways you could talk to the agent, but the app server is the real front door. It's the method you use if you want to build a truly rich, interactive, and powerful application.
And that really brings us to the final, most exciting thought. What OpenAI has built here is essentially a universal power outlet for a really sophisticated AI agent. By standardizing the plug, they've made it so much easier for any developer anywhere to build new things with this technology. So the real question this leaves us with is, what happens next? What incredible new tools and applications are going to be built now that this powerful foundation is in place?